Hey everybody, we're going to look at Lewis dot structures and polarity here. So for each of these structures below, we're going to draw the Lewis dot structure, and then we're going to determine if it's polar or nonpolar, and then we can make a prediction about what state of matter we would expect it to be in, although that's kind of the least official that we can do, but we'll still do it. Okay, so for CBR4, we have this is the Lewis dot structure. And again, this is not supposed to be a video on teaching you how to do Lewis dot structures. You can go see some of the previous videos for that. Okay. So that's the Lewis dot structure. So this thing is non-polar. And because it's non-polar, we would expect this to kind of be a gas. Okay. And so pH3, when we do this, pH3 looks like this. Okay. Remember that H doesn't want to have any more than 2 electrons around it. So if we look at this, that only has 2, this only has 2. So the extra electrons go around the central atom. And so because there's dots here, this is a polar molecule, and we would expect this to be a liquid. We can make a prediction about that. Okay, CO2, carbon dioxide. Okay, so just to give you an idea, we can go through the whole list of things that we can do for this. We can go and we can say that we can name this carbon dioxide. We can give the Lewis structure. We can say that this thing is linear. Okay, we can say that this is non-polar. And because it's nonpolar, we could say it's a gas. So there's all sorts of things that we can tell from the Lewis dot structure. So, just to keep that in mind. Okay, so NCl3, NCl, Cl, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay. So, and then the extras here. So because there's dots in the middle, this thing is polar. And because it's polar, we would expect this to maybe be a liquid at room temperature. And I've never messed with this compound, but I bet you that it's smelly too. Okay. Yuck. Okay. SF2. Okay. So SF2, we have S, F, 1, 2, 3, 4, 5, 4, 5, 6. Okay, so there's that structure. Okay, so again, because this thing has dots in the middle, it's polar, and we would expect the polar thing to be a liquid. Okay, H2O, this we know. I like having questions like this, and even carbon dioxide up here, because we know these. We're familiar with these things. So H2O, remember, if H is listed first, it's not the central atom. It's H. Looks like this. And we have dots around the central atom. Okay, and this is water. Okay, that thing is water. Okay, water is polar. And not only is water polar, but it is found as a liquid. Okay, so we should know that. You should be able to answer that question without drawing the Lewis dot structure. Okay, so then PF3, it's going to look like this. Okay, and so PF3, this is, because it has dots in the middle, this thing is polar, and we would expect this to be a liquid. And I would, again, I'm just trying to show you that there's more stuff that you can tell. I would expect this to be super corrosive and reactive. Okay, I would guess that this stuff is not fun to play with. Okay, then we have OF2, O, F, F, put the dots around it. Okay. And so this thing has dots, so this is polar, and we would expect this to be a liquid. Okay, and then the last one here, SeO2, SeO. Let's see, so this is going to look like this. Okay, and so now this is polar, and you'd expect it to be a liquid. Okie doke. So here we have it. These are the 9 structures and whether they're polar or non-polar. Okay, everybody, have a great day.